Hi everyone, welcome back to the Era of Experience. As you know, in the previous video in the series, we saw how human data kind of complements the overall learning through experience, right? In cases where the reward signal is not as simple as playing a board game where you either win or lose. The problem statements are abstract because here you're solving human related problems, stakes tied to human life, like discovering new drugs or new molecules versus alpha, like playing a game, which is zero to low risk exploration, right? So in that case, we saw human data kind of complementing the overall learning through experience, right? So the reward signal could be as abstract as, will this molecule bind to protein X? How do you decide that, right? Without any human involvement. You probably need a binding affinity predictor, which could be a neural network or possibly a human doing an experiment. Or is this fold biologically plausible, which often requires a structure validator, often trained on PDB data. So the paper is not screaming against human data per se. It's, remember in the first video when I started, I said how AI systems will learn will change everything. And in this case, how are you getting that human data will change everything? First is human data through static supervision, and here is human data directly through dynamic interaction, learning from the environment, direct feedback. That is going to change everything, and that is what the paper talks about. Maybe in the future you won't even need this human component as the paper envisions to where you can run simulations that won't even require this. But we will get to that in the next section. And now let me share my screen and just let us continue with our next section, right? So here the paper talks about the four characteristics of experiential agents. The paper says agents will inhabit streams of experience rather than short snippets of interaction. Their actions and observations. How will actions and observations be in the case of learning through experience? How will rewards be look like in the era of experience, and how will experiential agents plan and reason? And it kind of compares them as to how does an LLM do that, right? So let's get to the streams part, right? So the paper said LLM are the experiential agents are going to learn through streams of experience, continuous way of learning in the environment through experience, not like static one shot episodic how you talk to LLMs, right? Like you talk to LLMs, you have a session, one episode, right? And then gets over, you start another one. Whereas in the case of experiential agents, they will continue to learn throughout lifetime through ongoing streams of actions and observations, right? And here it said that's kind of how even we learn, right? We are in this environment and we get lots of feedback, we adapt, we are continuously adapting our whatever we have learned to work on things as things keep coming. And that's how experiential agents will be. So let me get to my notes and see what I have here. So yes, just a second. It was here. So yeah, here it says, suppose as I was talking, you go to ChatGPT, you ask a question, it answers, right? It does not explore or adapt. Meaning, when you are in a session with ChatGPT, you have that thumbs up or thumbs down button, right? That's kind of a reinforcement learning through human feedback. But the moment you provide that feedback, thumbs up, it is not going to update ChatGPT's model parameters then and there. You have to wait probably, when OpenAI releases another model or updates that model O3, O1, whatever, again undergoes its training through the GPUs. It's going to take a while, right? It's not happening in that real time. It's not updating its knowledge in real time. Whereas in here, is through streams of experience, the paper says, for example, a health and wellness agent connected to a user wearables could monitor sleep patterns over many months. So imagine like you have your Apple Watch or any other watch, Fitbit. It's getting all the feedback of your heartbeat or whatever activity you do, and it gets all sorts of feedback and it recommends you certain actions to perform basis on what the feedback you give. It is adapting in real time, continuous streams of experience. So this is what the paper means. But that begs another question. If, as I said, right, you have to wait for ChatGPT to get retrained. But that would essentially mean being ChatGPT alive, right? When the model is updating in real time, when you that would create another discussion, which basically means ChatGPT being alive, right, in real time. But that is a very serious question, and that we'll discuss towards the end section of the video. Believe me, it's one of the most interesting parts that is there to this video. And we'll see it soon. So let's now we have discussed streams. Let's now get to discuss about the rewards part first, and let's get started, right? So first, the rewards. What are rewards? As I said, in the case of remember that example where we talked about the child learning to ride a bike, right? In that case, the reward could be falling, or the child didn't fall, or it fell down. And if or in any case, you play a game, you win or lose, right? So every experiential agent will have a reward, pretty much like how humans also function, right? We do an action, we get a reward. Okay, this worked. I'm going to do this again. Or when we want to do something, it's probably because we get a reward. We get some reward nudge or some dopamine rush about it, right? So that's the case with how experience agents will also look. They will also have rewards, and they'll optimize for rewards, right? Now, first, the paper kind of talks about how does reward and experiential learning look right now in the current phase when it comes to large language models. So large language models also sort of inculcate reinforcement learning, but that is through human feedback. And when you go to ChatGPT, you can do a thumbs up or a thumbs down, but that doesn't update the model weights, as I said, right? And that particular reinforcement learning through human feedback, the paper says that is based on human prejudgment, right? An expert observes the agent's actions and decides whether it is a good action or picks the best agent action among multiple alternatives, right? So it says that reinforcement learning through human feedback, again, that human component is coming, which is grounded in human prejudgment. It's not based on actual consequences of your action. So in the paper, like if you go, it sort of gives an example of a cake, right? Of a cake recipe, where if you ask an LLM, it uses this example to sort of contrast how reinforcement learning works in the case of LLMs versus how will it work in the case of experiential agents. So when you ask an LLM, provide me a cake recipe, probably you are an expert or whatever you could be. You saw the cake recipe, you did a thumbs down if you like it, you did a thumbs down if you didn't like it, right? But where does RL agent make all the difference is here, instead of seeing the cake recipe, an RL agent will actually be there in the environment, making the cake, trying the recipe, and knowing whether it tastes good or not. So the RLHF in the case of LLMs isn't grounded in actual consequences. Without even seeing the consequence, the RL agent says that the person who's evaluating that response give a thumbs up or a thumbs down, versus the experiential agent will actually make the recipe, try the cake, and know whether it tasted good or not, and then it will adapt to its recipe or its weights or parameters on the basis of that. So this is what the model is talking about when it comes to rewards, right? So I'll now go back to my notes, and we will see what rewards are. So as you see, what we have here is every reward function is basically a mathematical translation of a human provided goal, right? The reward mechanism encodes human intent and values it into a signal that the agent can optimize for, right? So here the paper kind of talks about where do we get these rewards, right? Like sometimes it could be humans defining the reward, or it could be the rewards that are naturally present in the environment. The paper says this, that where do rewards come from if not from human data, right? So, and we see that here it says that can we build intelligent agents that learn from the world itself without needing hand curated reward labeled from humans, like non-human reward signals in the paper, where you play a game where you have where you win or you lose, which could be defined by humans. Or the paper talks about this environment, right? Our whole where we live in, it's filled with reward signals, right? Because mostly, like if you do any action has a equal and opposite reaction, right? Newton's third law. So if you are out to do something, if you have any task in mind, there'll be outcomes of the task, right? And it is the paper talks about translating those freely available outcomes of your task into a reward, right? And that is where it says, because the world is full of grounded observable signals, right? If you do something, you will have an output. It talks about these signals like cost. Suppose if you want to increase the cost of your product by doing some marketing strategy, right? So you did a marketing strategy, and then you sort of see, did the cost increase or go down, right? Error rates. If you want to optimize on error rates, you do something like X and you observe your error rates, did it go down or not? If you want to improve your blood pressure, you do certain actions, you will have the feedback that your body gives, or that whatever any instrument will give, right? So there is an abundance of feedback that is naturally present in the environment, and the paper envisions using this naturally occurring feedback signals from the environment in the reward signals, right? And that's what the paper is talking about. And the paper talks about, like, there are two ways how you get the reward. First could be a hard-coded reward function, and this is pretty common in many fitness watches that you have. I checked how Fitbit uses. They also have this custom defined reward functions, right? So suppose in this case, your reward, suppose your goal definition of what you want to do is you want to improve health, right? Which means reduce and stabilize blood pressure in this case, right? So engineers can create a reward function which is an absolute value of your current BP minus the target BP, and this is something that is actually there in the environment. The watch can probably take the readings, or you can specify and talk and provide the readings. And initially, what will happen is as we saw in the earliest case, we'll probably define a toolbox of steps. What the agent can recommend, and then but that toolbox of steps can be adapted as according to the feedback that you provide, right? So the toolbox of steps could be what you can initially in the RL setup, you can tell suggest walks, suggest outdoor activities, suggest a particular diet, right? And it will optimize those suggestions on the basis of the reward signal. So it'll suggest an activity, it'll check whether the blood pressure increased or decreased, and then it'll adapt its a strategy or whatever was mentioned in the toolbox steps accordingly, right? So it could be like after suggesting a walk plus meditation and observing the boiling, the blood pressure drop from 140 to 130, the target PP, you see, it then calculates the reward, right? And it kind of computes how does the reward, how does the reward match as to when you compare it to the feedback that you provided, right? So it can adjust its action, it can adjust its recommendation in accordance with the reward signal it gets, right? But this is sort of the standard reward signal that is quite common in many of the systems that we see, like Fitbit or Whoop, the smartwatches that are there, right? And then now the paper sort of talks about bi-level optimization, right? And this is something new which the paper talks about, where in case it talks about a dual approach, where you first have a lower level signal, which could be the actual environmental feedback to your that you get from the environment, and the next is the higher level reward, which is your major goal that you want to achieve. So it sort of optimizes the major goal with the lower level reward signal. So you have your signals from the environment, all the feedback that you get, and you have this major goal. So it uses this bi-level optimization to sort of give more personalized recommendations, right? So in the case of how do these signals look like? So in the case of drug discovery, the lower level signals could be binding affinity, like how did this molecule bind to a particular drug, and the higher level goal could be create an effective, safe medication for a specific condition. Right. So optimizing between these two factors to achieve what the problem is. So let's see an actual example as to how will it be. Right. So a higher level reward function could be, again, the designers would create it, which would be like a meta reward, get the user satisfaction and the goal achievement. Probably if the higher level goal, which is to improve health, is there, the user can probably give a feedback, or the agent can understand that itself from the feedback, right? Or the lower level reward function could be what you see from the environment, right? The lower, what we saw, what is really available. So that could be the action reward, could be the change in blood pressure in the case of if the goal is suppose improve health, right? So then in that case, the lower level signals could be blood pressure change, the sleep quality, the activity level, right? So it will get all this feedback, and then and it'll sort of update its weights in accordance to the feedback it gets from the high level reward function. So probably the user said that I'm feeling good after taking a walk, right? So it will gather that feedback, and then it can probably adjust the weight of this activity level, right? This activity level weight can be increased higher because the users, suppose it said that I am feeling better, right? So to improve that high level goal of improving health, the user said I'm feeling better, which kind of fulfills the high level goal, and that can be optimized on the basis of this lower level reward function, which is the activity level. The user said I walked and I feel better, so then it can optimize on this weight, right? So you see this overall process of actually learning through streams of experience instead of short snippets of information. This is what the paper is talking about. So the agent suggests actions and observes both environmental signals and user feedback. The system adjusts parameters in the function G to better align with function M. This is which is basically what I said right now, right? So the agent can probably say observe. It will first observe from the feedback. It gets the lower level reward function, and then it'll get some feedback. It'll act get feedback from reality and reinforce what worked, right? So it saw that when I recommend a good sleeping cycle, this higher level reward is fulfilled. So I'm going to do that again. I'm going to increase those weights again, right? So yeah, this is what it means by learning through actual streams of experience, right? So not through labels anymore, right? And let us look at how again, because the paper consistently uses this example of LLMs. How would LLMs do it to sort of illustrate how will superhuman intelligence look like? How would an LLM respond? Like when you instead of having this experiential agent which is continuously learning from the environment, you suppose you provide an LLM, all the feedback that you say, instead of the agent, the experiential agent working on it, you talk to an LLM about how you feel, right? You can tell the LLM, my BP is this. LLM can probably suggest walk daily. A week later, you can provide some other feedback. LLM suggest adding meditation, right? So and so forth, right? But you see here, LLM is basically answering from its static memory, right? From it's basically memorization, like intelligent memorization, versus in the case as we saw here, this is highly personalized, right? Because it is updating its weights in real time on the basis of the feedback that you provide. So here, this might not be personalized. This can be true for some of the time, because LLMs, yeah, it's based on static learning, and that learning is very good because it's based on all the possible good data, billions of parameters, and such a large data set it has been trained on. But what makes RL systems special is it is actually learning from you, something that is specific to you, your own experience. It's learning from that consistent feedback, right? Through that bi-level optimization, and that makes all the difference. So LLM, what's the case? Each recommendation is produced independently without a mathematical optimization framework. In the case you optimize on that framework that we saw here, the bi-level optimization, right? RL uses explicit reward signals to numerically optimize recommendations over time. Right. So another example to illustrate that, say after 6 months of data collection, the RL system might notice that the user's blood pressure significantly improves when they meditate specifically in the morning. This personalized insights specifically in the morning, have protein-rich breakfast, right? These are something that the LLM can never do, right? Because it doesn't implement that specific level of feedback that an RL agent does, right? So let me just may ensure that I've spoken whatever we wanted to. So yeah, let's just look at the paper again. So yeah, this is what we covered, right? Yeah, in this way, a small amount of human data may facilitate a large amount of human learning. And yeah, it talks about this bi-level optimization process as we discussed now. So yeah, this is what was about rewards. So instead of having one-shot human data, you sort of interact with the environment, and that makes all the difference, right? So yeah, this is how rewards will look in the era of experience. And we will in the next video we'll look at the other sections. Thank you.